Okay, hello everyone. So let us now proceed to solving exponential and logarithmic equations. Now we will use all of the properties that we have learned in the past video about properties of logarithmic equations. And especially in solving exponential and logarithmic equations, the following properties are very useful. The one-to-one properties, a raised to x is equal to a raised to y if and only if x is equal to y. Log of x base a is equal to log of y base a if and only if x is equal to y. And the inverse properties, a raised to the log of x base a is equal to x, and log of a raised to x base a is equal to x. Okay, so these are the most useful properties, but we will still be using the previous properties. So let's start with letter A. So these are exponential equations. So let's try to solve them. Okay, so let's start with the first one. So the first one, we have 5 e raised to 3x minus 4 is equal to 2. Okay, so let's add 4 to both sides. 5 raised to 3x is equal to 2 plus 4. We get 5 e raised to 3x is equal to 6. Now, um, we divide both sides by 5. E raised to 3x is equal to 6 over 5. So how do we find x? So in here, we can use the inverse property for a natural log. Okay, so ln e raised to 3x. So we take the natural log, both sides, and then for this, we know that from the inverse property, this will result to 3x equal to ln 6 over 5, and then x will be equal to ln 6 over 5 all over 3. Okay, so that is the answer. Okay, so let us now answer the second one. Okay, so let's answer the second one. You have here 2 multiplied by t raised to 2t minus 5 minus 4 equals 11. Okay, so let's add 4 to both sides. Equal to 11 plus 4. So this will be 5 is equal to 15. Okay, so we divide both sides by 2. Equal to 15 over 2. Okay, so how are we going to find t? So we use the inverse property again. So we take the log, both sides, and we use the base 3. Okay, so that we can apply the inverse property. Um, and then we know that from the inverse property, this will result to 2t minus 5. And then we will get log 3, 15 over 2. And then we add 5 to both sides. And then we find t by dividing both sides by 2. Okay, so that is your answer. Okay, so let's try to solve the third one. You have e raised to 2x minus 3e raised to x plus 2 is equal to 0. And now this might seem confusing if you can't see that this is factorable. So this is in fact factorable. So we can factor it by e raised to x. So minus 2, and then e raised to x minus 1, right? So if we do that, we can now apply the zero product property. E raised to x minus 2 is equal to 0, or e raised to x minus 1 is equal to 0. So now e raised to x is equal to 2, e raised to x is equal to 1. And now how do we find x? So we take the ln both sides. So we will get x is equal to ln 2. Okay. Those for the other side, we will have take the ln both sides. So we will get this will be x, and ln 1 is, we know that to be 0. Okay, so those are your answers for um, those exponential equations. So let's try now to solve our logarithmic equations. Okay, so let's start with the first one. We have here log 3, 5x minus 1 is equal to log 3, x plus 7. So what do we do with this? So if we go back to the first to the properties, we have here, we can apply the one-to-one property, right? So we can apply this second one-to-one property. So the fact that they both have the base 3 on both sides, then we can say that 5x minus 1 is equal to x plus 7, right? So then we just have to solve for x. So subtracting x from both sides, we get 4x minus 1 is equal to 7. And then adding 1 to both sides, we get 4x is equal to 8. Therefore, x is equal to 2. Okay, so let's go to the second one. So we have here 2 plus 3 ln x is equal to 5. So what do we do first? We subtract 2 to from both sides. We'll then get 3, right? And then what do we do? So we divide both sides by 3. So we will get ln x is equal to 1. Now how do we solve for x? So we use the inverse property again. If you go back to the properties, we can use this property right here. So this one, okay? So we will use that one. So what we're going to do, let's check that again. So yeah, so what we're going to do is we're going to uh, the left hand side and the right hand side let's treat it as exponents of e. Okay, e. Okay, so e raised to ln of x and then e raised to 1. So e raised to ln of x, from the inverse property, this will be x, and then so we have e raised to 1, or x is equal to e. I'm sorry. Okay, so so this is actually a correction in the in the learning guide. You have there x is equal to 0, so that was actually a typo. So this is the correct answer. And now let's go to the third one. We have here log 5, log of x plus 6 base 5 plus log of x plus 2 base 5 is equal to 1. Okay, so what do we have here? So based on the previous properties, we can the property with the product, we can say that this is equal to x plus 6 multiplied by x plus 2, right? And then this is equal to 1. Then what do we do? So just like what we did in the second second problem, we use the inverse property. So what do we do to use inverse property? We treat the left hand side and the right hand side as exponents of 5, right? So that we can use the inverse property. Okay, so this will then be equal to x plus 6 multiplied by x plus 2 is equal to 5 raised to 1, or that is equal to 5. Okay, so what do we do next? We multiply this, x squared plus 2x plus 6x plus 12 is equal to 5. So we will then get x squared plus 8x. This is plus 7, right? 12 minus 5, that would be 7, and then 0. Okay, so you will then get, we can then factor this to be x plus 7 and then x plus 1, right? Is equal to 0. Then using the zero product property, we can then say x plus 7 is equal to 0, then x plus 1 is equal to 0, and x is equal to negative 7, and x is equal to negative 1. Okay, so this is the solution to this logarithmic equation. Okay, so thank you for watching. I hope you learned something, and see you in the next videos.